Hi and welcome to this video, which is going to look at adding and subtracting fractions. Okay, so a good starting point is to think about what you know about adding and subtracting fractions. So let's take an everyday example. If I had a pizza and I ate half of that pizza, and then I ate another half of that pizza, how much of that pizza have I eaten? The whole thing. I think we could agree that if we had half a pizza and then another half a pizza, then we've eaten the whole thing. So let's try and turn that into a sum. That's what we like to do in maths. We take all of that language and turn it into a simple sum. So basically what we've said is 1/2 plus 1/2 equals whole or equals 1. Okay, so we've got to try and think, how does that work? How does that help us to understand how to add? Well, let's try and write it a different way. 1/2 plus 1/2 is equal to 2 halves. Let's try and draw a very rough representation. There's the whole pizza. So I'm going to cut it into halves. Obviously, they'd need to be equal parts. So if I had 1/2 and then I had another half, in language we'd say I had 2 halves, and in maths we'd just write it the same way, 2 out of 2, 2 halves. So we can write it like that, and then it's quite clear to see that by eating those 2 halves, what we've actually done is eaten 1 pizza. So 2 out of 2 equals 1. Okay, let's try another example and see if this makes sense. So this circle is split into quarters. So we've got 1/4 there, we've got another quarter there, we've got another quarter there, and we've got another quarter there. So if I take this quarter and then I also take this quarter, so I'm going to have this one and this one, I could say I've had a quarter plus a quarter, and so in total I've had 2 quarters. And then in the tradition of what we've been doing with fractions, we're going to simplify that. 2 quarters can be simplified to 1/2. They both share a factor of 2, so 2 quarters becomes a half. And as a visual, that's quite easy to see, isn't it, that those 2 quarters would make a half. But in the maths language, we need it to also make sense. So 1/4 plus 1/4 equals 2 quarters, and then we can simplify that to a half. But let's focus on this first bit, this adding of fractions. Okay, so what about if I added a 1/3 quarter? So I'm going to include this one. So I've got 1/4, 2 quarters, 3 quarters. And again, if you can get a visual on that. You can sort of shade it in a bit. I don't know if that's helpful or not. But we've basically got 3 quarters of the circle there. So 3 quarters. So let's explore what's happening when we're adding the fraction. Well, the denominator, the bottom of the fraction, is staying exactly the same, but the top is changing. We're adding up the top, the numerator. So have we got ourselves a rule for adding fractions. The denominator stays the same, the numerator is added. Well, let's try another example. So here I've got a circle, and this time it's cut into 8 pieces. Now they'd need to be exactly the same. So each one of these is 1/8. And we can go round and count them up. And of course, to make the total shape, we would need 1, 2, 3, 4, 5, 6, 7, 8 of them. So we could say 8 out of 8 equals the whole or 1. So if we're adding, let's just say we're going to take this one, this one, this one, and this one. So we can write that as 1/8 plus 1/8 plus 1/8 plus 1/8, and altogether we have 4/8. So again, we can see we're adding the numerator and the denominator is remaining the same. And we look at our final answer when we've added them up, and we're looking to see if we can simplify it. Can this be simplified? Yes. There's a common highest factor of 4. 4 goes into 4 once. 4 goes into 8 twice. So it's the same as a half. And if we look, the visual helps us to see that. Okay. Now, it doesn't have to be a circle. We can split anything up into 8 parts. It could be an amount, it could be a shape, it can be anything, as long as each part is the same. So again, these are still 8ths. And what we're hopefully starting to see here is that we're kind of arriving at a rule. So when we're adding, the numerators are added, but the denominator stays the same. And also, we can see that if we add them all together, this is going to take a while, then we are going to end up with 8/8, which equals 1. So we're starting to see some of the maths happening here. Now, if I'd have started this video with, if you want to add fractions, then you can add the numerator, but the denominator needs to stay the same. It wouldn't have the same impact as if you see it and believe it. Once you believe something, then the beauty of maths is that those rules will continue to work whatever the fractions are. But it's really important to be able to see why this rule works. Okay, so that's good. Now, what these have all got in common is we are looking at fractions that are the same. So we're all in this, we've been looking at quarters, we were looking at halves, and we were looking at eighths, and we were adding fractions that were all similar. And if you think about it logically, it's no different to saying I've got 3 apples and then I get another 2 apples. How many apples have I got? So you could say 3 apples plus 2 apples equals 5 apples. And the fact that they're apples doesn't change. We're just adding together how many there are. So you could think of this in the same way. 1/8 plus 1 more eighth equals 2/8. So if we had 2/8 and then we add, another 2/8, then we're going to get 4/8. So there's an introduction and food for thought. We're going to move onwards with this and look more at adding fractions and then also subtracting. But that's the end of this video.